I'm Anil Kumar. Welcome to my series on exponential functions. With the help of an example here, we'll actually try to understand transformation of a transformed function. So we have a transformed function f of x which is equal to 2 to the power of x plus 1 plus 2, and this gets transformed to g of x which is equal to 1 over 4 to the power of half x minus 1 over 4 minus 1. You need to state the transformations necessary to make this transformation. You can pause the video, answer this question, and then look into my suggestions. Now, to explain the transformation, let's get the same base at least. So for g of x, I could write this 1 over 4 as 2 to the power of minus 2. And then we already have an exponent here, which is half x minus 1 over 4 and minus 1. So that means I could write g of x as equal to 2 to the power of, let's keep minus outside, and inside if I multiply by 2, I get x minus half. And the vertical transformation, 1 unit up, down, right? So that becomes your g of x. And here we have f of x. Let's rewrite this. F of x in terms of 2 to the power of x plus 1 plus 2. So as you can see, we have the same base and becomes easier for us to explain the transformation. Now we have to go direct from here to there. How do we describe it? Well, the best way to go about is to consider the function y equals to 2 to the power of x right in the middle. Because basically both are the transformations of this particular function. Now if you keep this in mind, then let us see how do we transform each from here. So f of x, if I have to get this function, I have to do what? Well, horizontally, I have to translate 1 unit left. So 1 unit left. And this 2 gives me 2 units up. On this side, what are we doing? We have an additional transformation, which is reflection on y-axis. Let's write down. Reflection on y-axis. And then we have half unit right. And this means 1 unit down. So this is when we are considering from the base function, correct? These two sides. But now the idea is to write the transformation from here to there. That is what the question is. So now, once we have split into this fashion, we can now see what is happening when I move from here to there. So as far as the reflection on the y-axis is concerned, it is not there earlier, but we have to do it now. So one of the transformation here is reflection on the y-axis. Now moving left or right. 1 unit left, and here we say half unit right. So effectively, if you add these up, you are left with half unit left. Up and down. You've gone 2 units up, and now you're saying go 1 unit down. Well, so you're 2 up, and you have to go actually, this is your final result. You are going 1 unit down. So from 2 up to getting to this place, you have to go 3 down. Does it make sense to you? See, at this stage, you were 1 unit to the left, and here we are saying you reflect. So when you reflect and then get half unit right, So basically, the point is still on the left side. So when you combine these two, you say reflect on the y-axis. So you've gone to this side, and after that, you go half unit right. So you're still half unit to the left side. So that is your half unit left, right? So when you've gone 1 unit left, and if you go towards the right, you reach a position which is half unit left. That is what it means. So the combination is critical to understand. So let me mark this. Correct? So that is kind of a difficult link to understand, but that's what it means. Correct? Now we could also consider the transformation using the transformations itself. So we could actually rewrite this function g of x in terms of x plus 1 to give you an idea how to write from here to this place and then explain. So we could write g of x as equals to 2. We have made the same base to the power of. Now this is, first if I want to reflect this, then it really becomes minus x minus 1, right? Now g of x is minus x minus half. So I will do this as minus, right, x minus 1 plus half. So that gives me minus of x minus half. Do you see that? And then the y values are very simple to see, which is we were up 2, but now we are getting to minus 1. Okay? So this is the final result. So from the base function, we have gone down to minus 1. Here we were up 2. So difference here is 3 units. So that is 3 down. That's perfect. Here we can understand if we are trying to relate inside parts, right? So if you open this, I mean minus, if I take minus outside, in that case, this 1 will become minus, right? So minus of x minus 1 plus 2 makes it very clear that it should be half unit left, right? This is your half unit left. So I hope that helps. So our final result is from f of x to g of x, the transformation should be reflection on the y-axis, half unit left, and 3 units down. So finally, we got a transformation from f of x to g of x. It should be reflection on the y-axis, half unit left, 3 units down, right? So you could also write this as g of x now will be equal to the transformation. I could write like this. If my function is f of x, so we could write f here, and we are saying reflection on the y-axis, that means minus, half unit left, that means x left we have to go, so plus 0.5, that is half unit left, and 3 units down, right? So that becomes your final transformation, correct? Now it's a good idea to verify this with the help of set of points, right? So now we will actually check our result. Let's see if it is really correct. So we'll take set of points and then verify that this is indeed the correct transformation, correct? So let's do it on a fresh page. We'll again begin with the same question, but this time we'll take points into consideration. Well, sometimes that could be a better approach, right? So let us verify, right? So we have just discussed that if I'm going to write transformation from f of x to g of x, the transformation mentioned was these 3. First, we need to reflect on y-axis. And second was half unit left. And third was 3 down. Correct? So if that is the transformation, in that case, we can write the function g of x as equal to f of, so reflection on the y-axis means negative, right? Half unit left means x plus half or 0.5, right? And 3 units down means minus 3. Is that clear to you? So that becomes our transformation, correct? So what we are going to do now in this exercise is we are going to verify with set of points. Right? So we'll make a table of values with the points and do the calculation to verify. So let's begin with the base function 2 to the power of x. Okay. From 2 to the power of x, we'll get our function f of x and also g of x. The points on 2 to the power of x, which are always good to take, is minus 1 will give us half, 0 will give us 1, and 1 will give us 2. Correct? So if you're talking about f of x, then in f of x, if you go from 2 to the power of x, we know the transformation here is that x values, we have to take away 1, correct? And the y values are add 2. So we have y plus 2. As far as the g of x is concerned, we had reduced this, let me rewrite this, as 2 to the power of, we wrote this as minus x minus half minus 1, correct? So 1 over 4 is 2 to the power of minus 2, and you multiply, you get this. So if you go from here, the transformation is that the x points will get reflected, and then you have to add half, right? So add half. As far as y values are concerned, you do y minus 1, correct? Okay. So let's write down the x and y values. X values, just take away 1 from these, so it becomes 0 minus 1, and take away 1 will be minus 2 here, and this take away will be 0. Correct? So we get these values. As far as the y values are concerned, we have to add 2. So we get 2.5, 3, and 4. Clear? G of x minus this value will be 1 and 1.5. Take away 1 means minus 0.5. From this, take away 1. Minus is 0. Half means 0.5. Take away 1 means 0. And 1 minus 1 and add is minus half, right? Minus 0.5. Take away 1 will be 1. Correct? So we get this kind of transformation. Now, look here. We really want to check whether this is same as this one or not. Correct? So here, the transformation, if I go from f to, if I go from here, then what is the transformation? The x values will have minus of x, and this means minus of half, right? As far as the y values are concerned, we do negative 3. Clear? So y values, I think we have no doubt. X we need to verify. So let's check. So minus 2. So when I go from minus 2 becomes plus 2, and plus 2 take away 0.5 gives me 1.5. The y value, if I take away 3 from 2.5, I do get minus 0.5, correct? Which actually matches. Do you see that? So this is same. So the transformation is working out. With negative 1, it becomes positive 1, and take away half will be positive half. So we get 0.5. And taking away 3 from 3 leaves 0. And on 0, we get negative 0.5. And taking away 3 from 4 is 1. So we see that all these points, they match. Do you see that? So we have verified that this transformation, which we wrote here, is absolutely correct. Perfect. So you could actually kind of work out and check as we've shown here. I've done all this in details because many students have been having confusion, especially for this half unit left. Now this could be a multiple choice question here where that will be the right option, right? So that is why it is extremely important to look into this question in details. I hope you understand and appreciate it. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.